Okay, so today we're going to talk about recursive formula, which allows you to find the nth term of a sequence by performing operations to one or more of the preceding terms. So first we need to remember that the two different sequences that we look at are arithmetic and geometric. In the middle here are kind of our formulas for them. Remember that for arithmetic we call it a common difference, and that's adding or subtracting something to a number to get the next number in the sequence or the next term in the sequence. And then for a geometric sequence we call it a common ratio, which is something we're multiplying or dividing the first number by to get the second number. So first we'll look over here at finding the first 5 terms of a sequence. So we have A1, which is the first term of the sequence. And then we have A to the n equals 3a sub n minus 1 minus 12. So looking at that, we're going to find the first 5 terms. So we're going to use the first term, which is a sub 1, as 7 in the recursive formula to find the next 4 terms, because 7 is our first term, right? So let's try that. So to find a of 2, we're going to do 3 to the a of 2 minus 1, right? Because n is 2, and then minus 1, minus 12. So that's 3. Whoa. So that's 3. A to the 1 minus 12. So that's 3 times 7 minus 12, because our a sub 1, or our first term, is 7. So that's 21 minus 12, which is 9. So up here we're going to keep running. Our first term is 7. Our next term is 9. Now we're going to do for a, the third term. So 3a to the 3 minus 1 minus 12. So 3a to the second minus 12. Our second term is 9. So we have 18. Nope. Do your math right. We have 27 minus 12, which is 15. So then our third term is 15. If we worked out the next one, we would do 3 times, or to the 4 minus 1, so 4 minus 1 is 3, so 3 times 15, because 15 is our third term, which is 45, minus 12, that gives us the term 33. Next, we would do 3 times a sub 5 minus 1, because the fifth term minus 1, which is 4. 3 times our fourth term, which is 33, is 99, minus 12, which is 87. So that is how we find the first 5 terms in the sequence when they give us our first term and our recursive formula. Next, we're going to talk about how you write a recursive formula. So we have 17, 13, 9, 5, and those are the 4 numbers that they gave us. So first we need to figure out, is it an arithmetic or a geometric sequence? So we're doing 13 minus 17, 9 minus 13, 5 minus 9, and are we getting the same answer for all of them? That would tell us if it's arithmetic. So that's -4, -4, -4. Excellent. So we do. So that means we know that it's an arithmetic sequence. So then we're going to use the formula that was just right over here, right? So a to the n sub 1 plus d. So a n minus 1 plus d. So our difference is -4, and our first term is 17, right? So that's our a of 1. So our recursive formula would be a1 equals 17, and then a to the n equals a to the n minus 1 minus 4. because we're plugging in here. Well, that wasn't very effective. We're plugging in here, over here I'm highlighting. That is our common difference because it's arithmetic. And then here we're pointing out that our first term is 17. Moving down to this sequence of numbers, we have 6, 24, 96, 384. So first we're going to check and see if it's arithmetic. So we're going to do 24 minus 6, 96 minus 24, and 384 minus 96. 24 minus 6 is 18, 96 minus 24 is 72, 384 minus 96 is 288. So that makes it not arithmetic. So now let's try geometric. So remember, we're going to put our second term over our first term. So 24 over 6, 96 over 24, 284 over 96. If we simplify all of these, we get 4. So that makes it a common ratio of 4, and that also makes this a geometric sequence. So if that's the case, we know that our first term is 6, and then we need our recursive formula. So that's a to the n equals whatever our common difference is, or our common ratio is, which is 4, a to the n minus 1, right? Because we have our first term, and then we have our recursive formula that includes our common ratio. So ratio, common ratio for geometric, common difference for arithmetic. And just look at the placement. Because we're multiplying numbers together over here, so we're multiplying 4 times our number for geometric, because that's multiplication division. Then up here we're subtracting 4, because that's a difference or an arithmetic part of the sequence. That's basically the most important parts of a recursive formula, the difference between geometric and arithmetic, the difference between a common difference and a common ratio, how to find the first 5 terms using our recursive formula, and then how to use terms to find what the recursive formula is.